Question 1. Prove that the number of possible totals formed by rolling n dice, where n is a natural number, is 5n plus 1. Solution. Let's understand why 5n plus 1. The answer is very simple. The minimum total is n when all the dice show up 1, and the maximum total is 6n when all the dice show a 6. So it seems obvious that the possible totals are 6n minus n minus 1, because the first n minus 1 numbers are not possible. This gives a total of 5n plus 1. Let Pn be the statement. The possible totals are n, n plus 1, n plus 2, all the way up to 6n when n dice are rolled, n greater than or equal to 1. There are exactly 5n plus 1 numbers in the list star. Base case, n equals 1. The numbers 1, 2, 3, 4, 5 and 6 are possible totals in this case, so P1 is true. Inductive step. Suppose Pn is true. With n plus 1 dice rolling, one old possible total, namely n, in the list star no longer occurs. This is because each phase is at least 1. So when there are n plus 1 dice, the total is to be at least n plus 1. Observe that there are 6 new totals: 6n plus 1, 6n plus 2, up to 6n plus 6, corresponding to the case when the n plus first dice shows up 1, 2, 3 up to 6 respectively. All other numbers in the list star are possible. For example, the total n plus 1 will occur when the total on the first n dice is n and the n plus first die shows up a 1. Similarly, a total of n plus 2 will occur when the total on the first n dice is n plus 1 and a 1 shows up on n plus first die. Thus, the number of possible totals is 5n plus 1, which is the count in the list star, plus 6 new totals and minus 1 old total, which adds up to 5 times n plus 1 plus 1. So we have verified that under the assumption that Pn is true, then Pn plus 1 is also true. By the weak principle of mathematical induction, Pn is true for all natural numbers.